Imagine building a neural network that is deeper than VGG, more accurate than AlexNet, yet uses almost 25 times fewer parameters. Sounds impossible? This is exactly what Google's researchers achieved in 2014 with GoogleNet, also known as Inception V1. In today's video, we will not only understand what GoogleNet is, but also why it was needed, how the famous Inception module works, why one cross one convolutions changed deep learning forever, and we will even walk through a mathematical example step by step. Let's begin. Why GoogleNet was needed? Before GoogleNet, the CNN was landscape dominated by AlexNet in 2012, VGGNet in 2014. AlexNet achieved breakthrough ImageNet results. However, researchers noticed that deeper networks generally perform better. This led to VGGNet. VGG used 16 to 19 layers, very small 3 cross 3 filters. It had excellent accuracy, but there was a major problem. VGG had around 138 billion parameters. This caused huge memory requirements, slow training, high computational cost, and greater risk of overfitting. Researchers asked, can we build a network that is deeper but computationally inefficient? The answer was Google. The model learns features at multiple scales. Small features such as edges, corners, medium features such as textures, large features and large features such as objects. This multi-stage processing became the foundation of the Inception family. Let us do the architecture comparison based on depth parameters, efficiency and overfitting and innovation. The comparison is visible on your screen. It clearly means that 22 layers, that is 25 times fewer parameters than VGG of GoogleNet, wins the race. And it is remarkable. GoogleNet is deeper than VGG, much smaller than VGG, computationally more efficient. The answer lies in the Inception module. The genius is the one cross one convolution. The biggest innovation of GoogleNet was the use of one cross one convolutions. Most beginners think, how can a one cross one filter learn anything useful? Let's understand. Step 4 is concatenation. Outputs from 1 cross 1 branch, 3 cross 3 branch, 5 cross 5 branch and pooling branch are stacked together. This increases depth and combines information from multiple scales. The full GoogleNet architecture is the input image, then we get convolution layers, then pooling layer, then we get a Inception 3A module, then we go to Inception 3B module. Its output goes to a pooling layer followed by Inception 4A, 4B, 4C, 4D and 4E layers, followed by pooling Inception 5A, 5B layers and global average pooling, and at last the softmax layer. As discussed just a few seconds ago, you can go through this mathematical example with complete analysis, where the step 1 is convolution 1 cross 1 filter, then 3 cross 3 convolution filter, then we have a 3 cross 3 patch, this negative output, then we have a 5 cross 5 convolution followed by a max pooling, then all these outputs are stacked along depth final depth. This is the real world advantage over VGG. VGG fails for edge devices, real-time systems, memory-limited environments, but GoogleNet succeeds in all these applications such as mobile vision, embedded AI, and real-time detection pipelines. This is the complete layer-wise discussion of the GoogleNet architecture in a single window. As discussed earlier, you can have a glance at it. Another challenge with deep networks is vanishing gradients. GoogleNet introduced auxiliary classifier. These are small side networks attached to intermediate layers. It allows better gradient flow, faster convergence, reduced vanishing gradient problem. The key innovations was the Inception modules, multi-scale feature extraction, one cross one convolutions, auxiliary classifiers and global average pooling. As a result, this 22-layer deep model had only 5 million parameters, state-of-the-art ImageNet performance, and used for various real-world use cases such as autonomous driving, medical imaging, agriculture, leaf disease uses such as leaf disease detection relevant to your work, surveillance systems, successor models such as Inception V2, V3 and V4 and Exception had various advantages over the Inception V1. We can learn about this in the upcoming videos. With some advantages come some limitations also. It had complex architecture. It was not as simple as VGG. But in conclusion, we can say that efficient deep learning is possible by multi-scale feature extraction, dimensionality reduction, and sparse approximation. Key takeaway is depth alone is not enough. Efficient design matters. With this is Paper AI signing off with the GoogleNet introduction. Thank you.